Hi everyone. So in the last video, we saw how you could use limits to find the slope of a tangent line to a certain function. And in this video, we're going to be talking about how to actually write the equation of the tangent line. So when I say the equation of the tangent line, I literally just mean the equation of the line the same way that you wrote the equation of a line in like an algebra class, right? So just to show a brief visual, this was one of the examples we looked at last time. We had the function f of x is equal to x squared. And we found the slope of the tangent line at x is equal to 1 to be equal to 2. And so when I say find the equation of the tangent line, I literally just mean write the equation of the line that I graphed in green. So before we get into that, we're just going to review quickly how do you write the equation of a line. And there's two different ways of writing an equation of a line. I mean, actually, there's more than two, but there's two main ways that you've probably seen. And the first one you might think of is, y is equal to mx plus b. And so I'll remind you how that works, but we'll see that actually the more useful way of writing the equation of a line in this class is going to be to use what's called point-slope form. So that's what we're going to be using in this video. But first, let me just kind of remind you of how the other form works. So like two different, I'll say it this way, two formats for the equation of a line. So the first one is what's sometimes called SlopeIntercept form. And so that's the one that is like y is equal to mx plus b. So y is equal to mx plus b. What do those different parts represent? Well, the m tells you the slope, and the b tells you the y-intercept. So slope-intercept form is, it's nice because it can be easily rewritten in function notation, right? We could rewrite this as f of x is equal to mx plus b. But if you don't already know what the y-intercept is, it's not going to be as useful. So what we'll actually be doing is we'll usually be starting with our line in point-slope form and then rearranging it to put it into slope-intercept form. So how does slope-intercept form work? Well, slope-intercept form, or sorry, point-slope form. How does point-slope form work? So we talked about this. If you took pre-calculus with me, pre-calc 1, we talked about this. So the way that point-slope form works is that you have y minus y1 is equal to m times x minus x1. And so what do all these different letters represent? Well, m, same as before, represents the slope. And then what is this x1 and y1? Well, those tell you a point that your line goes through. So not necessarily the y-intercept, but just any point. And so this format is going to be really useful for us because typically when you're writing the equation of a tangent line, you don't necessarily know what the y-intercept is, but you do know another point that lies on your line. So I want to do an example of actually writing the equation of just a line without even mentioning tangent lines or anything like that. But actually one other thing I just want to quickly mention is if you're curious about like where does this formula come from, I think, or if you want something that might help you remember it, let me just kind of do that off to the side. So where does this formula or format come from? Well, slope is equal to, like if you're finding the slope between 2 points, you're going to be subtracting your y coordinates and subtracting your x coordinates. So x1, y1 is one specific point that lies on your graph. But then any other point that lies on your graph is also going to satisfy this equation. So that means that if you take this one known point, x1 and y1, and then you plug in any other point that lies on the line, it should have the same slope, right? It should have the slope of m. So we have the slope is equal to y minus y1 over x minus x1. If you just multiply both sides by x minus x1, that will give you m times x minus x1 is equal to y minus y1. And that's exactly the same as the point slope form that we wrote down. Okay, so let's do a quick example. So let's say that you wanted to write the equation of the line with a slope of 1/2. And let's say that we know that this line passes through the point -1, 4. So how would we write this equation? Well, we would just use that point slope form. So we would just say, okay, y minus, and our y coordinate in this case is 4, is equal to 1/2 times x minus -1. So you're just taking the y coordinate, plugging that in for y1, taking the x coordinate, plugging that in for x1. And so we can simplify this as y minus 4 is equal to 1/2 times x plus 1. And so this is fine. This is a legitimate answer. But sometimes, and what we'll usually be doing in this class is once you have your answer in point slope form, you want to actually be able to put it into SlopeIntercept form so that you can write it as a function. So I'll say that as, let's put this into function notation. So in order to put something into function notation, you need to have it set up as y is equal to something, right? Because then you can change that y into f of x. And so in this case, if we start by distributing that 1/2, so we get 1/2 x plus 1/2, and then we can add that 4 to both sides. So now we have 1/2 x plus 1/2 plus 4. So that's going to be y is equal to 1/2 x plus, so 4 is equal to 8 halves. And so 4 plus 1/2 is 9 halves. And so function notation would be f of x is equal to 1/2 x plus 9 halves. So that's how we can, you don't need to know the y-intercept in order to get your function or your line into this format. You can just start with whichever point you know and then transform it into y is equal to mx plus b form. There are other ways. So there's a method I've seen a lot of students use is sometimes students will write it as you'll write y is equal to mx plus b, and then you'll plug in your point to solve for b, and that's fine too. That also works. I tend to prefer this point slope form, but if you have a different way you're comfortable with, basically, if you're able to answer this example that we just did, whatever method you use, great. I just want you to be able to write an equation of a line with a certain point and a certain slope. Okay, so that's like exactly what we're going to be doing. So I think for some reason I found that a lot of students get a little confused about tangent lines. And I just always try to remind them that like you could almost answer these questions we're about to do in like a calculus class, like in like Math 98 at North. So there's not really much going on. It's just this extra step of using the derivative to find the slope of the tangent line. Other than that, it's just writing the equation of a line. So let's look at an example. So we're going to do a couple of examples from yesterday's video. So we'll see that these are ones where we already know the slope, and then we'll do an example that's just totally from scratch. So let's say that we wanted to find, so first example here, we want to find the equation of the line tangent to f of x is equal to x squared, that's this function here, at x is equal to 1. So every time you have one of these tangent line equations, you want to kind of split it into two steps. So the first step is, what is the slope? You need to know what the slope is. So in this case, we already did this in the previous video. So in the previous video, we found what the slope of this tangent line is. So in the previous video, we found that actually I'll say it this way. We found that f prime of 1 is equal to 2. So what does f prime of 1 mean? Just to remind you, that literally just means the slope of the tangent line. So i.e. the slope of the tangent line is 2. Okay, so that's the first piece of information we need, is the slope. The second piece of information we need is we need to know what is a point that our graph goes through, or our line goes through. So how do we find the point? Well, in this case, we have the graph right in front of us, so you can just kind of look at it. But let's say for a second, let's pretend we didn't have the graph. So we know, if we just look at what the question's actually asking, we know that we're writing the equation of the tangent line at x is equal to 1, right? So we know for sure that the x coordinate of the point it goes through is 1. So how would we find the y coordinate if we did not have the graph in front of us? Again, this is a question that has nothing to do with calculus. This is a question that goes just back to like an algebra class. So how, if you know the x coordinate, how do you find the y coordinate of a point on a graph? You plug that x value into the function. So we know that x equals 1 because that's they told us the tangent line at x is equal to 1. And so y is going to be equal to f of 1. And so in this case, f of x is equal to x squared. So f of 1 is 1 squared, which is just equal to 1. And so our point is going to be, and I guess maybe I'll call this x1, y1 because of the way that point slope is written down. So our point is 1, 1. And so once you have the slope and the point, well, then you can just go to point slope form. So point slope form tells us that we have, so point slope form, we say y minus the y coordinate, so the y coordinate is 1, is equal to the slope times x minus the x coordinate. And so now let's put this into like function notation. So we get y minus 1 is equal to 2x minus 2. And so that means that y is equal to 2x, if we add 1 to both sides, minus 1. And so our final answer, and maybe let's not call it f of x because that's already our other function. So we'll see this later in the quarter, but I'm going to use L of x. So occasionally you might use that. You could also just leave it written as y is equal to, it doesn't really matter. So let's double check that kind of makes sense with the picture we have, and it does, right? Because, I mean, I didn't draw this perfectly, but we can see that our line has a slope of 2, and the y-intercept appears to be -1. Okay, so let's do another example. This one's just it's gonna be very similar, but just have slightly less friendly numbers. So this one, our function was 1 over x. So we want to find the equation of the line tangent to, and let's call it g of x just to mix things up. G of x is equal to 1 over x. And we're going to do it at x is equal to 2. So again, there's basically just two things we need to do. The first thing we need to do is find the slope. And actually, let me just give us kind of a visual here. So our point here is at 2. And we have the slope like this, something like this. So this is the line that we're writing the equation of. And this one, I think is a little harder to, I at least don't look at this. I can't tell right off the top of my head what the equation of this one is, whereas the last one we did, if you draw it well, you can actually kind of see what the equation is. This one, because the slope is -1/4, that's what we found in the last video, it's just not going to be as easy to tell what the equation is without actually going through the steps. So in the last video, we found that g prime of 2 was equal to -1/4. And so that means that the slope of the tangent line is -1/4. So that's our slope. And so now we just need a point. So what is the point going to be? Well, we already know that x is equal to 2, right? We know that that is the x coordinate of the point we're looking at. And maybe let me just say something explicitly that I guess I didn't say earlier. The key fact here is that the point that we're working with, it lies on the tangent line, but it also lies on the function, right? So that's the reason why we can find the y coordinate of the point, because not only we're using this point to write the equation of the line in green, but because this point is shared between the tangent line and this function g of x, that's why we can actually find the y coordinate by plugging the point into g of x. So the y coordinate is going to be g of 2. And so the function g of x is 1 over x, and so that's going to give us 1 over 2. And so now we can, we have our point is 2, 1/2. So now we can put this in point-slope form. So we have y minus 1/2 is equal to, and our slope was -1/4, and then we have x minus 2. So solving this for y, we want to distribute that -1/4, and so we get -1/4 x, and then -2 times -1/4 gives us a plus 1/2. And then we can add the 1/2 to both sides, and so we get y is equal to -1/4 x plus 1. 1/2 plus 1/2 gives us 1. And so I'll write it again in this L of x form, but you could also just leave it as y is equal to. So looking back at our graph, I didn't do the very best job, right? It should have had a y-intercept of 1, but it seems reasonable, right, that would be the equation of the line. And that's always a good check to do, just because it's really easy to make some kind of an algebra error when you're doing these problems. And so just looking at the graph to be like, does that even make sense, is a good thing to do. Because let's say that the tangent line actually looked something like this, well then our answer would not seem to make sense. So you want to be just seeing, does it look like it's in the right ballpark? Okay, we're going to do one last example, and this is going to be just from scratch. So imagining now, or not imagining, but actually not knowing what the slope is just yet. So this time we're going to find the equation of the line tangent to f of x is equal to x squared minus 4x. And we're going to be doing that at x is equal to 6. So again, we want to break this down into pieces, and we're not going to look at the graph this time to help us. We'll look at it once we're done, just to kind of see again whether our answer makes sense. So the first step is to find the slope. So in this case, we don't know yet what the slope is, but we know how to find it, right? Because that's what we spent the whole previous video on. So how do we find the slope? Well, we want to take the derivative at x is equal to 6. And so that's what means going back to that limit definition of the derivative that we covered in the last video. So we're doing the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h. So this is one where I think it's definitely going to be helpful to write out what f of 6 plus h and f of 6 are kind of off to the side individually first before you attempt to simplify this, because otherwise I think things can get a little crazy. So we know that our function is f of x is equal to x squared minus 4x. So if we wanted to find f of 6 plus h, that means that we're replacing x with 6 plus h. So we want to say 6 plus h squared minus 4 times 6 plus h. And then we want to simplify this. So 6 plus h squared is going to be 36 plus 12h plus h squared minus 24 minus 4h. So altogether, this is going to give us, so 36 minus 24, that's 12. And then we have 12h minus 4h, so that's negative 8h. And then we have plus h squared. And then what is f of 6? F of 6 is going to be equal to 6 squared minus 4 times 6. And so that's equal to 36 minus 24, which is 12. So now we can go and put those back into our expression here. And by the way, if you took pre-calculus 1 with me, this might be a little familiar, right? We did something called difference quotients in pre-calculus 1 that was basically doing stuff just like this. And that's the reason why. It was in order to practice it so that when you get to calculus, it wasn't like completely foreign. So I guess I don't generally tend to use that word within the calculus class, but this expression that we have here is something that's called a difference quotient. Okay, so let's put in our new numerator. So our numerator is 12 minus 8h plus h squared minus 12 all over h. So the numerator, these 12s are going to cancel out. So we have a positive and a negative. And so we're left with the limit as h approaches 0 of, and sorry, I just realized I made a mistake. So this should have been a positive 8h. Sorry about that, right? Because we had a plus 12h and a minus 4h, so that should have been plus. My bad. So now we have 8h plus h squared over h. And we can factor out an h from the numerator. And now we're able to cancel it out. And we're left with the limit as h, wrong color, approaches 0 of 8 plus h. And so now we can go ahead and plug in h is equal to 0, and we find that our slope is equal to 8. So that's the first step, is using derivatives to figure out what is the slope of the tangent line. So that's really the only part of this entire process that requires calculus. So our next step is to now find a point that this line goes through. So looking back at what we're doing, the line goes through x is equal to 6. So to find the point, we can say, okay, we know that the x coordinate, we'll call it x1, is equal to 6. And so the y coordinate is going to be equal to f of 6. And we actually already calculated that, right? We did that up here. F of 6 was equal to 12. So the point that we know that our line goes through is going to be the point 6, 12. And so then the last step is just to put this all into point-slope form. So we would get y minus 12 is equal to 8 times x minus 6. And so that's y minus 12 is equal to 8x minus 48. And that gives us y is equal to 8x. And if we add 12 to both sides, we get minus 36. And that's our equation. I guess I'll just leave it written as y is equal to. So let's look at the graph and kind of confirm that that is correct. I believe it is. Yep. So here's our original function, x squared minus 4x, looks like this. And then here I'm graphing, so I have the point 6, 12, and then here's 8x minus 36, and that is our tangent line. All right, so that is it for this video, and I will see you all the next one.